Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Certification Bootcamp. In this module, we'll demo the Application Load Balancer configurations. This session is going to be a hands-on, so get ready to get your hands dirty. We have covered all the theoretical concepts in the previous module in greater depth. If you are starting from this module and need to brush up your ALB concepts, I recommend reviewing the previous module before diving into this demo. We will start by configuring the load balancer targets, which are basically EC2 instances. We'll turn them to simple web applications where we can route the traffic. Instead of manually installing the HTTPD servers and configuring the web pages, we will use user data. Next, we'll configure the application load balancer with the required security groups, target groups, and listener rules. We'll also configure target group health checks and see how application load balancer can detect unhealthy instances and route traffic only to the healthy instances. Finally, we'll enable sticky session and demonstrate the session affinity feature. If you want to follow along with us, log into the AWS Management Console. Throughout the demo, we will stay within the AWS free tier, so you won't be billed anything for this lab. We have a lot to cover. Let's jump into AWS Management Console. I have logged into AWS Management Console and let's go to EC2 dashboard. Currently, we don't have any instances running, so let's launch the instances. I'll click Launch Instance. I'll try to launch 2 instances. The name we are going to provide after launching the instance. So now I'll keep that name as blank. For application and OS image, I am going to use Amazon Linux and I am going to use Amazon Linux 2023 kernel 6.1 AMI version. In terms of instance type, I am fine with T3 micro, which are free tier eligible. Key pair, I am going to select proceed without a key pair because I am not going to SSH inside these EC2 instances. Network setting, I am fine with the default VPC. However, I am going to use the existing security group. From the security drop down, I am going to select CES demo security group. Storage configuration, I'll go with the default. I'll go to the advanced detail and I'll scroll down to user data section. And now let me explain what that command is going to do. We are going to start with #bin bash, that is the initial command. That means we are going to add some bash command. We are going to do yum update y. First, we are going to check if there is any pending updates in the EC2 instance and we are going to make all the updates. Then yum install y HTTPD. We are going to install the HTTPD server. With -y attribute, I am going to provide the confirmation upfront such that it is not going to halt the installation and it will not ask me to provide yes or no. With systemctl start HTTPD, once HTTPD will be installed, we are going to start HTTPD and then we are going to enable HTTPD. Then we are going to create a simple HTML page under var www/html directory and the file name will be index.html. Let's rename this hello world from, instead of hello world, I have written hello world from Cloud Expert Solution ALB demo. I am going to also post the IP address of the EC2 instance such that we will be able to understand which EC2 instance is serving the traffic. Using the $hostname -f, we are going to read the private IP address and we are going to type that private IP address in the web page. Now everything is good for me. I am going to launch the instances. It is going to take between 30 seconds to minute. Let's go back to EC2 dashboard. I'll click instances. The instances are running. However, I'll allow you to pass all the status check. I am going to pause the video here and I'll be back once all the status checks are passed and the instances will be ready to use. It took more than a minute. Now both the instances are ready and you can see all the status checks are passed. Now let's rename the instances for easy to understand. For the first instance, I am going to provide the name as CS load balancer target group 01, and the second instance I am going to rename as CS load balancer target 02. I have both the instances renamed. For the second instance, load balancer target 02, private IP is 172.31.36.243 and the public IP is 52.206.105.222. Now let's copy the public IP and let's try to access the web page. I am going to use HTTP because we are not using any TLS certificate. Then the public IP /index.html. Let's enter. Here you go. Hello world from Cloud Expert Solutions ALB demo. EC2 IP address is 172.31.36.243. And similarly, let's try to access our first target. I'll copy the public IP and I'll access the web application. Similarly, here you go. Here the private IP is 172.31.38.217. Let's review. Yes, 172.31.38.272. Now our both the targets are ready. Now let's create the load balancer and attach this target with a target group. To create a load balancer, I'll go back to EC2 dashboard. From the left hand side, under load balancing, I'll go to load balancers. I'll create load balancer. Here are the different load balancer options: application load balancer, network load balancer, gateway load balancer, and there is a previous generation load balancer called classic load balancer. AWS does not recommend you to create classic load balancer. We haven't covered the other load balancers yet. However, we are going to cover the other load balancers in our next video. So let's create application load balancer now. I'll click create. I have to provide a load balancer name. Let's use the name as CES load balancer demo. You can choose whatever the name you want. There are two different types, either internet facing or internal, that is private load balancer. I want to create internet facing. Load balancer IP address IPv4. Network mapping, I'll go with default VPC. I am going to select all the availability zones such that the load balancer can distribute traffic across the availability zones under USTist 1, and these are all the availability zones from USTist 1A to USTist 1F. Security group, instead of default security group, I am going to create one new security group. Let's click create new security group. I am going to use the name as CES load balancer demo security group. You can choose whatever the name you want. For the description, I am going to use Cloud Expert Solutions load balancer demo. I'll select the default VPC. Let's add inbound rule for that security group. We want HTTP traffic from anywhere. That is why instead of custom TCP, we are going to select HTTP as the protocol. Default port range is 80 and source as anywhere IPv4. Outbound rule, we are fine with the default rule. Let's create the security group. Security group has been created. Let's go back to application load balancer creation page. We will refresh the security group drop down and let's select the newly created security group CES-LB demo SG. We are going to remove the default one. In terms of listener and routing, we need to create the target group. Let's create the target group first. In terms of basic configurations, we already reviewed the different types of targets. It can be instances, it can be private IP addresses, it can be Lambda functions, and it can also be an application load balancer. Let's use instances. For target group name, I am going to use CES demo TGT or target group. For protocol, we are going to use HTTP because we do not have any TLS certificate. If you have a TLS certificate, you can use HTTPS and the port will be 443. However, we are going to go with HTTP. IP address IPv4. Protocol version HTTP1 is fine for me. We are going to come back for the health check configuration. For the time being, let's keep the health check. Let's go to next. Here I have the available instances. Both are in running condition. I'll select both and I'll include as pending below. Now I have attached them into the target groups and I'll create target group. My target group has been created. Here healthy is 0, unhealthy 0. Let's go back to load balancer creation page. I'll refresh the target group drop down and let's select the target group. I am not going to add any tag. Configuring CloudFront, web application firewall, we haven't covered anything. We are going to cover in a future video. And now let's create the load balancer. Let me close this pop-up. Let me close this pop-up as well. And here is our load balancer. If you will go to load balancers, here you can see the current state is provisioning. Let's allow the load balancer to be created. It may take between 30 seconds to minute for the load balancer to be provisioned successfully. Our load balancer is currently active and it provisioned successfully. It took almost a minute. Now let's select the load balancer and review different attributes. Here are my listener rules. I have configured the protocol as HTTP and port as 80. Here I have only one rule. Now let's go to network mapping. Here I have the VPC where the load balancer is created. The load balancer is spanned across the 6 availability zones. If I go to resource map, here you will be able to see one diagram. It starts with the listener. I have only one listener. Then I have only one rule forward to the target group. And then I have target group which has 2 instances or 2 targets and both are healthy. Now let's go to security. Here we have the security group. We also have monitoring. These are nothing but CloudWatch dashboards. We haven't invoked any load or we haven't passed any traffic to load balancer. That is why you won't see anything. In terms of integration, you can configure application recovery controller. You can configure CloudFront, global accelerator, AWS config. You can also add web application firewall to stop any OSI layer 7 attacks like cross-site scripting, SQL injection. And we do not have a production workload. That is why we are not going to configure application load balancer as of now. But now let's go to details. Let's copy the DNS name and let's try to access the application. Here you go. You can see hello world from Cloud Expert Solutions ALB demo, EC2 IP, and the IP address is 172.31.36.243. 36.243. If you will go to our EC2 dashboard, target group 2 has 36.243. Now let's refresh and we are getting the response from target 1. Now let's refresh couple more times. 36, 38, 36, 38. Now you can see application load balancer is distributing the traffic between the 2 targets or the 2 EC2 instances and we are getting the response back. Now let's play around with the security group. We'll go to the EC2 dashboard. We'll select the security tab. We'll go to security groups. And here are our inbound rules. We have one inbound rule which is allowing HTTP traffic on port 80 from anywhere. We are going to edit the inbound rules and we are going to delete this rule. Now let's save rule. Now we have only one inbound rule, that is to SSH into this instance. Now let's go to individual instance. Previously we tried to access using that instance public IP. If you are going to refresh, let's refresh the other instance as well. And you can see now it is thinking and it is clocking. After some times you will see timeout because the EC2 instance security group is not allowing any direct traffic to these instances. We are getting timeout from both the instances. Here you can see this is for the first and this is for the second instance. Now before accessing these web applications from load balancer, we need to update the EC2 security group and we need to allow traffic from the load balancer security group. Let's go back to the EC2 security group. Let's add one more inbound rule. I will add the rule and I will allow HTTP traffic on port 80 from load balancer security group. Our load balancer security group name is CSLB demo SG and I am going to save the rule. Here you go. The EC2 security group has been updated successfully and now it is allowing HTTP traffic on port 80 from the load balancer security group. Now let's review the EC2 instances directly. If we'll try to access the web page directly from the EC2 IP, it is clocking. That means it is going to get timeout. Same thing for the second EC2 instance. However, if you try to access using load balancer DNS, I'm still getting the response and the load balancer is distributing the traffic between the two backend instances. Now let's go back and review the health check. To review health check, I'll go to target group details. Here you can see I have 2 healthy instances and 0 unhealthy. Now if I'll go to health check tab, while creating the application load balancer, we haven't specified anything and we are using the default health check. We can edit the health check. Here we have the health check on HTTP or HTTPS. If you are selecting HTTPS, please make sure you have the TLS certificate, or else you are going to get the unhealthy targets even if your EC2 instance is running. I'll switch back to HTTP. From advanced health check details, here are different parameters. Healthy threshold is 5. You can configure between 2 to 10. 5 is default. The number of consecutive health check success required before considering an unhealthy target as healthy. 5 consecutive health checks must be passed by the backend targets. Unhealthy threshold is 2. That means 2 consecutive unhealthy responses or 2 consecutive failures will be considered the target as unhealthy. Timeout is 5. The amount of time in seconds during which no response means it will be a failed instance. You can configure the interval between 5 to 300. The default is 30 and success code is HTTP 200. Now let's update this timeout as 2 seconds. Now let's update this healthy threshold as 2, the default, because we don't want to wait long. And the timeout is also 2 and interval as 5 because we want to try the unhealthy instances. Now let's save changes. And now I am going to stop one EC2 instance. I'll go to security group from EC2 dashboard. From instance state, I am going to stop the instance. Let's wait for the instance to be stopped. Now the EC2 instance stopped successfully. Let's go back to our target groups. Still it is showing 2 healthy and 0 unhealthy. We can go to targets. Still both the instances are showing healthy. Let's refresh. 1 is changed to unused and target is in scope. You can see 1 is changed to unused from healthy. If we come back to details, here I have 1 healthy. We can do one more thing. We can go back to EC2 dashboard. Let's remove the filter. For this EC2 instance, let's start the instance and let's change the security group to a security group where we do not have any inbound rule which allow traffic from the load balancer security group. Now for this, I'll go to security. This is the security group we have, CES demo SG. Now from the action, security, change security group. I'm going to add the default security group and I'm going to remove this security group. Save. Now this instance is running. Let's review the security group, the default security group. We have one inbound rule which is allowing all traffic from all port. Now let's remove this inbound security group rule. I am going to delete. I am going to save rule. Now we do not have any inbound rule for this security group. Back to my EC2 instance dashboard. Our target 2 instance is running, although the status check is initializing. Now let's go to our target groups. Here we have the target group. Let's select and let's select the targets. You can see out of that, now target 2 is unhealthy and target 1 is healthy. Now let's try to access this application. If I'll hit the application load balancer DNS name, now you can see this IP is not getting changed and we are always getting response from the target 1. Let's hit couple more times. And you can see we are getting from target 1. And now let's go back and change the security group of that second EC2 instance. I am going to remove the default security group. Now I am going to attach the CES demo security group and save. Security group has been successfully updated for the target 2. Now I'll go to the target groups, the targets. Here you go. Now both the targets are healthy. Let's try to hit the application load balancer DNS. Here you can see application load balancer understand if a target is unhealthy and it will route the request only to the healthy instances. Now let's review the sticky session. I'll go to application load balancer. I'll go to the target group. And for this target, I'm going to edit the target group attributes. Here you have traffic configuration. Either you can use round robin. Currently we have the round robin. That is why one request is going to target 1 and the second is going to target 2. You can also provide weighted random or the weighted. And here is the target selection configuration. Here we have the stickiness. You can turn on the stickiness and you can use stickiness duration between 1 second to 7 days. Let's put 30 seconds and let's save changes. Now we have enabled sticky session. Now all my requests for the 30 seconds should go to one target. Let's go back to application load balancer. Let's refresh couple more time. And you can see now the response is going to one target and it is not changing the IP. It will take some time for the sticky session to be expired. Now you can see the request reached to the new target or the target 1. And if you are going to hit again for the next 30 seconds, all the requests from my laptop will go to target 1. Now let's review listener and the rule configurations. For that, I'll go to load balancer. Here we have the listener and rules. I'll click the listeners and rules tab. I'm going to add a new listener. Now here are the configurations. For listener, you can select either HTTP or HTTPS protocol. Since you already have one HTTP protocol with port 80, we won't be able to configure another one listener with the same port, or else it is going to create conflict. That is why let's select port 81. In terms of routing action, either you can forward to target groups that you have already reviewed. From here, you can select the target group. We already have one rule for target group, or else you can redirect to an URL and you can provide the URI path or even the full URL. And here is the full URL path and the status code what you want to provide. Or you can return a fixed response. For fixed response, you can configure the response code. Either you can use HTTP 2XX, that means 200, 202, or HTTP 4XS or 400s and HTTP 500s. Let's select HTTP 500. Content type, you can provide either application JavaScript, application JSON, text CSS, text HTML, text plain. Let's select application/JSON and the response body, whatever the custom body you want to provide. Response body is optional. For this demo, I am not going to add anything, and then you can add the listener. Here you go. Now we have two listeners. By this way, for your use case, you can create more than one listener for one application load balancer, and you can assign target groups to these listeners. Using this listener protocol and port, you can forward traffic into different target groups. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.